We're going to use our calculator to find these numbers that we were just finding. So we're getting kind of warmed up towards that. So these formulas, when will I use the formulas, Mr. Dirksen? Well, z-score, if you have all these three pieces here, you may always use this formula. If you know the actual value, if you know the mean, if you know the standard deviation, you may use this one if you want to find a z-score. Again, when am I going to use this formula? If you want to find the actual value given a z-score, a standard deviation, and a mean, okay, you may use this anytime you want. Okay? Sometimes I have no choice but to use them. Sometimes there's other ways of finding either the z-score or the actual value. So we have that. Hopefully you have that written down. And we didn't finish answering all of these questions. So we had the heights of males in Canada, right? We had our mean in the middle, and we've got 3 standard deviations to either side. That is 99.7% of data is going to be comprised between those two, between those extremes, right? And there's a little bit on the tails here, but we don't bother with it. If you're taking this at university, you may have 4 standard deviations to either side. It could be rare, okay? Rare, but it doesn't mean that 3 is all we ever do. You could go 4 to either side, but 3 has almost everything in it, so we're done at that point. So let's keep answering on 26. Here, what percentage of males have a height with a z-score between -2 and 1? Okay. So what is a z-score? If you have a -2 is -2 standard deviations, right? 2 standard deviations below the mean. That's what that is saying. And that is +1 standard deviation above the mean. So what are the 2 values that we have there? -2 standard deviations, go over to 25. That would be 172 centimeters, right? And 1 standard deviation positive gets us to 179.5. Okay. So we want everything in between. How many standard deviations are there between +1 and -2? There are three gaps, right? How do you know that, Mr. Dirksen? I'll go over here. There's this 1 right here, and -2 is there. So there's 3 standard deviations there. I just realized because it's 2 to the left of the mean and 1 above the mean, that's how I figured out that it's 3. Okay? So we know that this is 34, this is 34, and this is 13.5. So I'm not making a fancy bell curve here. This is just for you to see. Okay? So we have 13.5 plus 34. You may go 68. Okay, it doesn't hurt if you just go 68 if you know it's 34 and 34. And that ends up being 1 second here. 81.5. Yeah. I haven't made a little note there. 81.5 is the percentage there. What is the range of the heights that would have 95% of males comprised in it? We already answered this before. I just reworded it, okay? We've answered it here, up here. 95% means 2 standard deviations to the left, 2 standard deviations to the right. If you go up here, maybe tell yourself there's the mean. Okay, there's the mean is always in the middle, but 95% tells me that it's 2 to the left and 2 to the right. That is the range. So we'll just say 172 centimeters to 182 centimeters. So I just read off. So this is the low, and this is the high end, okay, of the range. And here's where this one I need you to understand this one. So I'm going to actually, the space here is not the ideal, but let's talk about this here. The mean height for females is 162.5 centimeters with a standard deviation of 3. Sketch both curves, okay? It says here, sketch means it doesn't have to be perfect. It doesn't have to be to scale. sketch both curves on the same plane. How will they differ? Use different colors to illustrate the differences. Let's make a little chart here first. Males, and then we have the mean and the standard deviation. Okay. And what's the mean for males again? It's 177 centimeters. And the standard deviation is 2.5 centimeters. Females, it's 162.5. Standard deviation is 3 centimeters. Let's talk about the mean first, okay? Which one of these graphs is gonna have the mean higher up along the x-axis? If you just look at these numbers. This one, correct? Okay, so let's make that first. Let's determine that first. So grab a ruler. Where did my ruler go? Oh, right here. So we're just gonna make a line here. And this line it's a sketch, right? So this will be height in centimeters. So this one is higher up the x-axis. Higher up x-axis. So let's go and find that along the x-axis. We're gonna have that somewhere higher up here, and we're gonna just make a dot right here. This is for the males. That's where the 177 goes. All right, and so the females will be where? Further down, right? Somewhere here. That's 162.5. So that's the first thing you need to do here. Where along the x-axis are there means? Okay. Next, let's look at the standard deviation. Put your thinking caps on, okay? Which one of these is going to be steeper? Males or females? Males, because it's a smaller standard deviation. So this one is steeper. I tend to focus on which one is steeper. You may want to focus on which one is flatter. It doesn't matter. So what does that mean? We're going to go to where the males are, right? And we're going to make sure that this one is higher up. And then we go to the females and we just make sure that one is a little lower. Right? So you kind of make that distinction. This is just to see if you understand what the data is telling us. And then let's do two different colors, okay? Or you can do dashed or solid, whatever works for you. So I'm gonna go, maybe for males I'll go orange, because that's the first highlighter I grabbed. And I'm just gonna go ahead and draw my curve. And make it steep, okay? Like, don't taper off too much. And then I'm going to go females. And it's down the x-axis. It's right here. It's flatter. Okay? That's how, this is how it would be if you had them both on the same graph. That's the pattern you would observe. So the mean tells you how high up you are on the x-axis, and the standard deviation tells you, right, if you compare which one is steeper compared to the other. Okay. I hope that made sense. I wanted to spend a bit more time than just to give you the answer there. Calculate the z-score. Look at this, right? Calculate the z-score. That's hint, hint. You got to use a formula. Calculate in math, even for grade 12, it means some sort of work that needs to be done there. Of a male with a height of 181 centimeters, what does this tell us? Let's calculate. Z-score, and the formulas are right next door there. X minus X bar, that's how you say mean, by the way, X bar. 181 minus, what's the mean in this particular case? Is for males, right? So that'd be 177. Make sure you do that first. Divided by the standard deviation, which is 2.5. When you subtract that, you get 4 positive, could be negative, right? And that's 2.5 divided by 2.5, which ends up being positive 1.6. So the z-score for a male with this height is 1.6. Let's investigate. Does that make sense? Go to the graph. So the height is 181, right? Where is 181 centimeters approximately? It is past 179. It's somewhere in here, right? So wouldn't it make sense that it is more than 1? Your z-score should be more than 1, right? 1.6 it ends up being, 1.6 it ends up being this. So it's somewhere over here, okay? So you should be able to do this math, and it should jive with your graph. If it doesn't, then you're in trouble. So what does this tell us? This part right here. A male that is 181 centimeters tall, right, is 1.6 standard deviations and this is the key word here, above the mean. Why? How do I know that? Because z-score is positive. That's how I know that it's above the mean. If it had been negative, you'd be below the mean. So if I just said, like, what do you think my z-score will be? I'm 196 centimeters, I think, last time I checked. So if you do the math, what would that be? 196 minus 177, oops, divided by 2.5. 7.6, according to this, is my z-score. So does that mean I'm tall? If I just told you my z-score in terms of height is 7.6, you should already be able to tell, like, whoa, that is very tall. That's like 7.6 standard deviations from the average, right? So, and if someone comes along and says my height puts me at a z-score of -2, you should know right away that's below the mean, right? So, just so you know, I didn't know that my z-score was 7.6. This is the first time I did the z-score based on my height. But, anyways, determine the height of a male with a z-score of -0.4. Okay, so that's when you use this one. And what's the formula again? Z times standard deviation plus mean, right? So now you want to find the actual score, actual height that is connected with this z-score. We know that this person is below average, right, when it comes to height. And so -0.4 times standard deviation. What's my standard deviation again? 2.5 plus whatever the average is. When you do the math here, you get -1 plus 177, and that ends up being 176 centimeters. I'll just make a note coming off of this. Z-score is negative, therefore below average. Okay. All right, so we've done a little bit more with the formulas here. Let's go to 27. I got that started. So this is what I'm going to ask you to do. Maybe you already did this. Okay. So if you go to 27 and 28, I'm going to give you, this is your last chance before we do the calculator part, okay? Work through these questions, and a little bit towards the end of class, I'm going to hand out an AC that you take home. Take home AC that's based on this, okay? I think I posted the answer key to 27 and 28 already. Did I post the answer key? I think I did. So if you did it, you're good. Maybe if you work through this, you still have some questions. This is your chance to ask me, all right? So don't just sit there, enjoy the free time. Come and ask me if you're not sure what you're doing, okay? So 27 and 28, completely done. Oh, sorry, I actually meant to say to 30. I think I did 27 to 28 yesterday, but I'm going to tell you right now, 27 to 30, I would like you to work on that. So I don't do this very often, but I need to give you, it's crucial to understand what we're doing here before we do the calculator part, okay? You need to be able to be very comfortable with graphing your bell curves, all of that stuff. So I'm going to give you some class time to work, and then towards maybe the last 10 minutes or so, I'll give you that AC, so if you want to get started in class, you may do so. But first, I want you to work through this. So. Grab a seat, guys. Grab a seat. I want to explain this for ACs or tests or quizzes moving forward. If you get to a question, let's say on page 30, some of you got to 30, so way to go, guys. If you get to this page, does it ask you to make a bell curve? It doesn't. However, when I don't ask you for it, you can just do a quick line where you have your mean in the middle and you just go 1, 2, 3, 1, 2, 3. Put the numbers there. I will not judge you or take marks off if it's just a very bad looking graph, but all you want is the numbers here. Okay, and then you can quickly just tell yourself this is 34, 13.5, 2.35, and 0.15. Like you put the numbers down, and so if I ask you, right, how many dogs are between 8.4 and 14 kilograms, you should be able to just look up the numbers down here. Does it say, what does it say? Number of dogs, right? How many dogs? Will the bell curve ever tell you how many dogs? It will give you percentages. You need to first figure out the percentages and then find out how many dogs that would be, okay? All right, look at my key, it's posted.